Hello everyone, my name is Marcin Sendera and I will talk about our work, HyperShot, few-shot learning by kernel HyperNetworks. This is a joint work with Marcin Przewięźlikowski, Konrad Karanowski, Maciej, Zieba, Jacek, Tabor and Przemysław Spurek. Let's start with the few-shot problem, which is a standard meta-learning setting where we have a large number of different small tasks and we try to generalize to the new ones. We can imagine a large number of various real-world scenarios that satisfy the few-shot assumptions such as image classification, object tracking problem, or regression. In our paper, we are focusing strictly on the most popular few-shot scenario and image classification problem. To give you a quick overview of few-shot learning setting, let's imagine that you have plenty of small image classification tasks. Each task consists of a support and query set of n randomly sampled classes. Training and testing classes are sampled from separate class subsets, and you have to classify images from the query set based on the support set examples. Our contribution could be quickly summarized into three main points. First of all, we introduce a novel few-shot learning model. We dubbed our method as HyperShot as it combines powerful hypernetwork framework with kernel methods. Moreover, HyperShot is created in a specific way, in order to produce decision strategies which do not go directly from the gradient optimization. Finally, HyperShot utilizes kernel methods that aggregate information coming from the support set and are perfect indicators for the hypernetwork to produce the specific weights for the classification target network. How does it look in practice? The general idea is simple and could be summarized on the architecture scheme. The HyperShot could be divided into three main parts: module processing of the support set, hypernetwork itself, and the classification module for the inference. Let's dive into all of them. To solve task T, we first process the support examples through convolutional encoder E and generate kernel KSS. Next, hypernetwork H transforms KSS into the weights of target network T. Network T classifies a query example Q based on the value of kernel KQS between it and the support set. We tested our HyperShot method on a wide range of benchmarks. On this slide you can see the results on the 5-way one-shot task on the CAP and mini-ImageNet datasets, and also in the cross-dataset setting, where the meta-training part was done on the datasets like OmniGlot or mini-ImageNet, and the meta-training on different datasets. We observed that HyperShot achieved state-of-the-art or comparable accuracy on all of these tasks, especially the cross-dataset ones. Considering 5-way 5-shot task, the overall results were similar. Let's do a quick summary. We proposed the novel few-shot learning method called HyperShot. HyperShot combines the hypernetworks and kernels for producing the specific set of weights for each few-shot task. Finally, HyperShot is able to produce different decision strategies than typical meta-learning methods based on gradient optimization, and as such achieves state-of-the-art results on a variety of few-shot benchmarks. Thank you for your attention and listening to this presentation.